Hi, grade 8 students. This is day 18, lesson 10-5. Page number 524, number 7 through 33, the odds. Before we get started, pause this video in a few seconds and take a look at pages 520 through 523. Carefully read them. Thank you. Okay, hopefully you read through the section. It's not real difficult. You've had this kind of work in the past, but the one thing that 8th graders get tripped up on is sometimes determining what the bases and the heights are of certain particular shapes. So that's probably where I'm going to spend most of my time in this lesson today. Let's start by first looking at the formulas for a parallelogram. Area equals the base times the height. The question is, what is the base and what is the height? For a triangle, it's area equals 1/2 times base times height. And for a trapezoid, it's area equals 1/2 times height times the adding up of the two bases. In your book, it says A plus B, but they're bases, so I decided to write B1 and B2 up here. Same difference. Okay, let's take a look at this. Let's imagine we have a parallelogram, so I'm going to start with parallelograms. And I draw the parallelogram like this, and I tell you that the distance down here is 10 inches, and I tell you the distance here is 8 inches. Do you have enough information to find the area of the parallelogram? The answer is no, no. The formula says base times height. What we've got here is, somebody might say, a length and a width. If you study carefully your book, you will notice that the base and the height have a relationship based on the concept of a perpendicular distance going away from the base. Okay? And that's what I'm trying to show right here. Here we have the base. The base cannot be the 8 because we don't have a perpendicular distance going away from it. And our height is, in this case, this number right here, whatever it is. Now let's say, for example, I put 6.5 inches or 6.5 inches. We would find that the area in this case is 10 times 6.5. Or in other words, 65 square inches. In other words, in this particular shape, we have 65 boxes that are 1 inch by 1 inch in size throughout this shape if we sat down and drew it all out. Area equals base times height. Now, keep in mind that sometimes they'll kind of try to trick you. What if I drew a parallelogram that looks similar to the one I just drew, slightly different? And let's say I put a number of, how about 9 inches here, and a distance of, how about 8 inches here. And then I drew a dotted line here, and I put a 90-degree angle symbol here, and I wrote the number 8.5 inches right here. What would be our base and our height in this particular case? Somebody might be tempted to say, well, the base is at the bottom, right? So my base is 9, and maybe my height is 8.5. That would not be the case. Remember I said the base and the height have a relationship. The base and the height have to be joined together by that perpendicular nature. And so the base in this case would be the 8. That's our base. And the 8.5 is our height. So in this particular case, area equals base times height, we'd have 8 times 8.5. Now what would that be? That would be 68 square inches in this particular case. Okay, same thing holds true with triangles. Triangles. We have to be careful what we decide to be the base and what we decide to be the height. If I draw a triangle that looks like this, and I put a dotted line right here, and a 90-degree angle symbol here, and I call this 7 inches, and I call this 9 inches, and this 11 inches, and I call this particular measurement here 6 inches. There's 4 different numbers on the board. Which one's the base and which one's the height? Well, that perpendicular nature still applies between the base and the height. Our base is 11 and our height is 6 in this case. So using our formula, 1/2 times base times height, we get 1/2 times a base of 11 times a height of 6. And that would be an answer of 33 square inches in this particular formula. Okay? Sometimes this gets a little bit tricky in that if you have a really obtuse triangle like this, a whole lot of numbers can occur in this situation. For example, let's put a 7 inches right here. Let's call this 10 inches. Let's call this 14 inches. And then I'm going to put a dotted line here and a dotted line here. And I'm going to put the right angle symbol here. And I'm going to tell you that this measurement right here is also 7 inches, and that this measurement up here is also 6.5 inches. Now, with all that being said, I've got 5 different numbers there. Which one's the base and which one's height? Area equals 1/2 times the base times the height. Remember we said the base and the height are related to each other because of that perpendicular nature, right? In this case, the base is this particular 7 right here, and the height is the 6.5, because the height is going away from this base in a perpendicular nature. So in this case, it would be 1/2 times 7 times 6.5. Don't know what that is offhand. 1/2 of 7 is 3.5. So we're going to take 3.5 times 6.5, and we get an answer of, syntax error. 19.5 square inches. So that would be the way we'd handle that. Most of your problems are going to be a little bit simpler than this. What do you do, though, with a case where you have, say, a right triangle? And let's say you have numbers of 6, 8, and 10. Which of those particular numbers are going to be our base and our height? Well, the 8 and the 6 are related to each other by means of this perpendicular line segment, or excuse me, this perpendicular symbol, rather. And so we would ignore the 10, and in this case, it's 1/2 times a base of 8 times a height of 6. And so in this case, it would be 4 times 6, or 24, whatever we're talking about. How about in this case, square feet? Finally, parallelograms. I'm sorry, trapezoids. What do we do with a trapezoid? Let's start with a rather strangely shaped trapezoid. That looks like this. I'm going to put a right angle symbol here, right angle symbol here. I'm going to give you all sorts of numbers here. We're going to talk about this being 6 inches, 7 inches, 10 inches, and over here, this is going to be 8 inches. The formula says area equals 1/2 times the height times the adding up of the bases. Well, how do you find the bases? The bases are the two sides that are parallel to each other. So in this case, it's the 7 and the 10 that are the bases that get added up. And what's our height? Our height is the perpendicular distance between the two bases. So what is our height? Our height is the 6. So 1/2 of 6 is 3. 3 times 7 is 51. This particular shape would have an area of 51 square inches. But that's not a typical trapezoid, is it? A typical trapezoid would look something more like this. Now I'm going to give you a lot of numbers. We'll start with 12 and 7. I'm going to put a dotted line here with a perpendicular sign here and call this 5 inches. We're also going to call this 6 inches, and we're going to call this 7.5 inches. Now I've just given you 5 different numbers. Which of those 5 numbers are we going to call the height and the base? Well, remember, the bases are the 2 parallel sides, so that would be the 7 and the 12. The height is the perpendicular distance between the 2 bases. In this case, it's 5. So what's 1/2 of 5? 2.5. What's 7 times 12? 19. What is 19 times 2.5? Don't know. I get 47.5. And our label, because it's an area problem, is square inches. Okay, hopefully this helps you. Thank you for coming to this video today and watching it. Have a great day, and as usual, if you get stuck, give me a call at 517-242-3138. Thank you.